Hi, I'm Tinny from minibulldesign, and today I'm going to talk just about my windmill. Some people have asked some questions about it and want the numbers on it. So today I thought, for lack of anything else, that I would just talk about the windmill. So let's sit down and share and run the numbers on the windmill. Okay, here we go. Now, I built that wind turbine or windmill, I like to call it a windmill, from scratch, from a set of plans. I got those off the internet, and if you want a set, I think they're $25, and all you got to do is Google U-H-U-G-H Pigott, P-I-G-G-O-T-T, U Pigott, and he has a website called Scourge Wind Farms or something like that, and he has a lot of pictures, a lot of information, a lot of graphs on building windmills, and he also sells plans. And the plans cover several different sizes, so you can build whatever you want. There's a 4-foot model, an 8-foot, and a 12-foot. That's an 8-foot. That means from the tip of one blade to the tip of the other blade, if you draw a circle all the way around, it's 8 feet across. Now, the stumbling point of windmills is the tower. That's the toughest part to come up with. This tower was given to me by a friend named Frank Swan. It's his old ham radio tower. He bought a new one. That one was damaged some, and it was just piled up at a friend's place, and he gave it to me. I welded it up and painted it and put it up. Now, to give you an idea of the stumbling point of a tower, and that has been up for maybe 5 years, and it's never attempted to come down, and there's a reason for that. I started out by taking 1,000 pounds of cement and pouring a pylon in the center and mounting the main tower to that. Then there's 3 anchor points, each with 1,000 pounds of cement on them, and on top of those is bolted with bolts that go right into the cement, 1-ton boat winch on each one of those pylons, so I can loosen cables or tighten them to steer it around to get it to stand up perfectly straight. Now, it has to be absolutely straight. If it's leaning one way or another, since it pivots and it's heavier on the front than the back, if you lean it one way, it'll just pivot over that way and it won't have enough power to swing itself around into the wind. So it has to be perfectly straight up and down. Enough for that. The windmill itself has a stator in the middle that's 3/4 of an inch thick. And I made that with fiberglass cloth, polyester resin in a mold. I poured that. I made the mold according to the set of plans, put the cloth in, then I wound, I think, 12 coils out of about 60 thousandths magnet wire, 80 winds each, and those all set in that mold, and they're all wired together with a common loop, and it's complicated. And then the resin is poured over them and more fiberglass cloth. And when you get done, you have what's called a stator. That is mounted on a framework, and then in the center of it, there is a big hole where a hub comes through. The hub is one hub off of a boat trailer, 4-stud. Now, there's a 1/4 inch thick by 12-inch metal disc on the hub, and then spacers and another disc on the other side, further out on the hub, and the stator is in between these 2 discs. These discs have a dozen 1-inch by 2-inch by 1/2 inch thick rare earth magnets. I can't pronounce the other name. Rare earth magnets. A dozen on each disc, 1 for each coil. And they're evenly spaced apart and right directly in front and in back of the coil. Now, they're set up so that they have a negative and positive pole. They're set up so each one, if it's negative on one side, it's positive on the other, and then positive, negative, negative, positive. So that when they turn past the coils, you're continually getting a magnetic pulse. Negative, positive, back and forth. And that's what generates the electricity. The closer you get them to the coils, the better. These have an air gap of about 3/32. Now, the blades for this, I originally made wooden ones, but they got badly damaged one time when we had a high wind with hail, and it was spinning really fast, and the hail was going through it, and it chewed up the leading edge. So I bought a set of fiberglass blades off the internet. That was 3 fiberglass blades with the hub for $84. I don't think you can beat that with a stick. Total cost to build the main windmill was about $300 for wire and magnets and fiberglass and metal and all the other stuff. Now this windmill, when it turns, it has to get up to a certain speed before it generates any amount of electricity, probably, I don't know, 50 RPMs, and it probably wound right up, turns 300 or 400. I'm just guessing on that, I don't know. But what I want to tell you is, as it turns, it produces what's called wild AC. Okay, what's wild AC? Okay, you take any one coil, when a positive goes by, it pulses one way. When a negative magnet goes by, it pulses the other way. So you've got wires coming out, and two wires, negative, positive, negative, positive. That's the way they pulse. If this one's negative, that one's positive, then this one's positive, that's one's negative. Each time it goes past the coil, it changes. So it's pulsing back and forth, negative and positive, and that's alternating current, negative, positive, sine wave. And the voltage varies from obviously 1 volt up to about 15 volts. So you've got 15 volt maximum, 15, 16 volt maximum AC current, which is, as far as I can tell, absolutely useless and good for nothing. So what you do is, those wires all come out. There's 10 wires because of the number of coils. 10 or 12. Anyway, they go into a rectifier bank, and they're wired up so that the rectifiers straighten out the current. So that when you come out of the rectifier bank, you've got 2 wires. One's always negative, one's always positive, and it's pulsing. But it's all, if this one's negative, it's pulsing negative. This one's pulsing positive, so they're the same all the time. And they're pulsing at whatever rate the windmill is spinning at. And that's just how it works. And the voltage depends on the RPM of the windmill. Those wires, the wild DC, go into a battery bank. Now, a 12 volt battery bank. Now that battery bank doesn't care whether they're pulsing or not. Could make no difference to them whatsoever. What it does care about is that the voltage is higher than their internal voltage, which is 12.8. So if the voltage coming out of the windmill is anything over 12.8, it's charging the batteries. And they'll sit there and soak up anything that windmill can dish out. And it will just build up in the battery pack. I don't have that many batteries on it now, but it should have about 20 12 volt used forklift batteries would be ideal. I haven't done that because I haven't got another story, but that's what it should have. And those will just suck up whatever current the windmill dishes out on a windy day. Now from there, those 12 volt batteries are all wired so they come out 12 volt and goes into a power inverter, which takes a 12 volt and turns it into 110, which you can run anything in your house off of. The inverter I have now is just a cheap one. I did have a pure sine wave 1,000 watt inverter, but it got struck by lightning. Yeah, it happens. Now that pure sine wave puts out theoretically the same current as you get off of the grid, so you can run computers and televisions and all kinds of things off of it. And that was supposedly a pure sine wave inverter, but my television didn't like it and wouldn't run off of it. Hey, go figure. Maybe I didn't spend enough money, I don't know. But anyway, that's how the whole thing works. The tower is 60 feet tall, and I have what's called a gin pole that's 30 feet tall, and that's the lever for lowering it and raising it. The base is on a hinge. I lower it every couple of years and do some maintenance on it. So far I've had to put 2 sets of bearings on it, but I used the grease sparingly on the first set, and that was the downfall of it. They got dry. The second set I used more grease, thinking that the grease would create drag and slow it down. This last time, this third time around, I packed it right full of all the grease I could get in it. And I think it'll last a lot longer that way. Now, if you want to know what shape your bearings are in, when the wind's blowing and it's spinning really fast, you can just walk up to one of the cables, the guide cables, and put your ear on it and listen. It's like a stethoscope. And if the bearings are rough, you'll hear it. If the bearings are running very smooth, it'll just make a nice wavy whine. If the bearings are rough, you'll hear a grating sound. So you can tell the health of your windmill simply by walking up and putting your ear on a guide wire. The guide wires are 1/4 inch, 17 strand galvanized steel. If you want to go crazy, you can go with stainless steel, but I think that's probably overkill because those have been on there like 5 years and they haven't even started to rust or anything yet. I think that's everything I can think of on the windmill right off the cuff. Most of the wind I get in the wintertime, there isn't that steady a wind in the summertime. But in the late fall and winter, it's very windy. This is rated for 500 watts, a 1/2 kilowatt. That means if it ran at its maximum for an hour, it would produce a 1/2 kilowatt. 2 hours to produce a full kilowatt. That's very misleading because you very seldom ever have enough wind to have it run at the full 500 watts. It usually produces between 50 and 300 watts on a really, really good day. And it very seldom runs for more than 10 minutes to a time before the wind dies down, and then the wind will come back up. So it's very misleading. It doesn't produce enough electricity to really do much of anything. I did run my machine shop on it for quite a while. I had a bunch of batteries on it, but all my equipment is very low, and requires very low wattage. I think my lathes at the time, I had 4 lathes, only ran one at a time. They took like 75 watts to run them. Very, very low power. And it worked well for that. Where they really shine is for lights. If you have a house and you want to use lights, it works very well for that. Lights aren't that watt intensive, and it's very forgiving. Works real well for lights, and that's what I would recommend doing it for. You can use it for small appliances also, but it's not anything you could steadily run like a freezer on or anything like that, because sometimes you'll have a few days where there's no wind and your batteries will die on you. So, I'm Tinny from minibulldesign. Get out and hike, take a friend. Enjoy the great outdoors, and more important than anything, try to have a really great day and try to take some time out to have just a little bit of fun today. Bye-bye.